review what prime numbers were. Prime numbers, think to yourself, are numbers whose factors are 1 and itself. So now we discussed briefly that prime numbers can be building blocks due to how simple their structure is, given that they only have 2 factors. Well, this directly applies to today's video, which is about prime factorization. Pretty much imagine you can write any number, like let's take for example 9 as a product of separate primes, like 3 squared in this case, since 3 is its only prime. And numbers like 12 can be written as 2 squared times 3. So every number has some unique product of primes. So this is really powerful since we've broken down numbers to this level, so it's easy to compare stuff, which this comparing idea will be talked more about in the GCD and LCM video, which is coming up next. The main purpose of today's video is to understand what prime factorization is and how do we get from the number over to this nice factorization. So far we know that prime factorization breaks the number down and it's unique to each of the numbers, so no 2 numbers will share the same prime factorization. So now we're going to discuss a pretty simple algorithm which is used to find the prime factorization. Let's take for example a bigger number like 36. What the algorithm does is you start at the smallest prime and then you just keep dividing it into the bigger number. So 2 is the smallest prime, as we saw in our last video. So dividing 2 into 36 gets us 18. Then we can continue the process. So do 2 again, and it says 9. Now you can see we can't divide 2 in here anymore since 9 is not evenly divisible by 2. So then we can divide by the next smallest prime, which is 3. So then that gives us 3 here. Then you can do that again, divide by 3. So then you can get that and 1. So what's important to note is 1, that you're increasing order, and 2, you stop the process when you hit 1. So you just end it when you hit 1. Now after you do this chain of divisions, you count how many of each prime are there. So I'll say 36 is equal to, you see 2 2's, so 2 squared times 2 3's, so that's like 3 squared. So that's a prime factorization of 36. Now that you somewhat understand this process of doing the prime factorization algorithm, let me give you an example for you to pause the video and try it on. Find the prime factorization of 60. So please pause the video and we'll discuss shortly. Okay, let us go into this. So dividing by our smallest prime, which is 2. One thing to note also is that 2 is the only even prime. So meaning that if you have an even number, you should by default divide by 2, since 1 is the smallest prime and 2 is the only prime, which could be dividing it. So doing that, we get 30. Then again, even number, so in my mind I automatically go to 2. Then we get 15. Now notice how 2 doesn't divide 15 anymore. So then we can say a number like 3. That's our next prime. So then by doing that we get 5. Then you have 5 again, since now that's the only one which divides. And then you get 1 and you end the process. So now you can actually count how much of each thing are there. We have 2 2's, 1 3, 1 5. So then you can write 60 as 2 squared times 3 times 5. And that is it. So now that we understand how to find the prime factorization, this is a really powerful tool in number theory where we can do more complicated things in the future, which you'll actually see in our next video. So stay tuned. Thank you for listening, and I hope to see you then.